In this video, we're going to go over multiplicity of polynomials. And for the given example, we're going to factor by grouping first two and last two. We can factor x squared minus 9 further. And by setting equal to 0, we can find zeros with multiplicities. So we can say that x equal -3 with multiplicity 1, because we have 1 there. X equal 3 with multiplicity 2. So the exponents outside of the parentheses are called multiplicities. So if we have x minus c with odd multiplicity, and when that multiplicity is equal to 1, then our rough sketch of the graph will look like either this or this. It will cross the x-axis. If m equals 3, 5, and so on, then the rough sketch will look like either this or like this. It will be flatter near the, you will have a flatter graph near the x-axis. So when x minus c with even multiplicities, then it will either look like the U shape or the downward parabola shape. So basically it will bounce off and make a turning point. It will touch the x-axis and make those parabola shapes. So in order to sketch the graph, we also need to find y-intercept by setting x equal to 0, which is 27. We're going to find the end behavior. Because the degree is odd, cube for our case, and the leading coefficient is positive, we have positive 1 here. We know that as x approaches infinity, y approaches infinity. As x approaches negative infinity, y approaches negative infinity. Now we can graph by plotting -3, +3, and the y-intercept at 0,27. Because of end behavior, I know that my graph look like this. And because of multiplicity 1, when x equal 3, you know that it will cross the x-axis. And when x equal 3 with multiplicity 2, because it's even, multiplicity is even, we know that it will bounce off at x-axis. So for this case, we don't really need sign analysis, just like the previous video, because we're using the multiplicity along the end behavior, y-intercept, and x-intercept.